Hello there. Today we will see how we can make the part drawings in the AutoCAD and yes, obviously in the 3D modeling, and we will see the assembly of the spigot and socket joint in the 3D modeling of AutoCAD. So I will open a new window here and I will turn this mode into 3D modeling. So my workspace is now in 3D modeling. I will dock the command box. So I will go to my folder where my details of the 3D modeling is there, and I'll copy this here. I'll copy the image of the details which are given. You can see the details I have already copied. It is an image file. It is good that if the image file is there already in your workspace, so unnecessary you don't toggle the windows. Okay, so what we see here in the details is we have the socket. The socket, we have the socket end, one number. Cast iron is the material. Okay, and what we see is the sectional front view of the uh, socket end. What we also see is the spigot end. The spigot end is one number, again cast iron material, and the cotter here. The cotter is basically is in mild steel, and we can see all the radius and the sizes given. Okay, the thickness is given as 6 and the taper is on this side while the other side is flat. The socket end is given in the sectional front view while the others, the spigot end is in the front view, cotter is also in the front view. So our main aim is to make the 3D parts of this 2D drawing, assemble them and recreate a sectional front view, a side view and a top view in the 2D plane. So step 1, we will start with the 3D part modeling for the socket end. Now in order to do that, what we will do make is we will go actually, you can see here. Okay, so since this is in 3D, we will make sure that we are going to the southeast isometric so that we can check the 3D views, so front, right and top, and we see that it is a left hand side view, so we can also get the right view. So I will click on the right and I will say align my plane to this view. So my XY plane is aligned to this view, and you can also see that here with the grid. Okay, so now the next thing is we are going to try and we are going to plot this dia 64, and dia 64 is 25 mm in the thickness. So circle, select the circle, select center anywhere. Okay, in order to go into the diameter mode, I will press D and press enter. Now I am in the diameter mode. I will enter the diameter 64. I will enter diameter 64 and press enter. So I have the circle of diameter 64. I have to extrude that up to thickness of 25. So extrude, select this object and give the length of 25, and there it is. In order to change, or you can see the 3D view also. So it is already a disc of 64 diameter and 25 thickness. Going back to 2D wireframe. Now our next aim is to draw another circle. You can see this, that is diameter 44, and the total length of this dia 44 will be 62 plus 20, that is 82. So coming back here, now my plane is already aligned in right. So either you can select the face, and you can select the face here, and you can align that as per your requirement. Okay, so now here I will select the circle, select D, press D, enter for diameter mode, give the diameter 44, press enter. Now I have purposely selected the center of the point circle outside so that I can move them after I have completed this. I will select the center of this and select. Okay, so these are concentric circles now, and from here only I will extrude this up to a length of 82. Okay, so what is next? We have extruded up to a length of 82, and now we have up to diameter 25. The shaft diameter is 25 on both the ends. Okay, we are assuming that here it is not given, but we will take that as dia 25, and this dia 25 we are going to take the length also like more than 25, so we'll take the length of 30, and we'll come to the same plane. Now here you have an option to go back to the right plane, or you can select, since you are already in the plane in this orientation, you can make a circle anywhere in that space on the plane, diameter 25. Okay, and you can move the circle from its center and align it to the face of the next plane we wanted. Okay, so in this case you did not change the planes here. Okay, it will be more easier. We go to extrude and we extrude this by 30. Okay, so we have the exterior part of the spigot end, and what we now require is the internal hole, that is dia 32, which will be there for the spigot end to go inside. So socket, now we already have the socket here. I will come to this part. Okay, or you can also always get southeast or southwest isometric directly. Okay, again same thing, circle, diameter 32, align this or move to this plane, make sure you are putting it on the correct plane. Okay, and now I will extrude this first, extrude this up to a length of 87, that is what it is given there. Okay, you can check. Okay, that is 25 plus 62, that is 87. The total length of the dia 32 is 87. So that is what we have done. And now I'll change this to conceptual. These two solids are different, you can see. Okay, so here we are going to first make a union. So I will take the solid outer 1, 2, yes, this outer solid, and 3. So I will take these 3 and make a union and press enter. So now we can see all this are one body. Now I will subtract. So click on the subtract, click on this object, enter, and then the object with it. Press enter again, and you have the Boolean operation done. Okay, yeah. So now we will go back to our coordinates and we'll see this. So we have the front with us. We have the front view of the socket joint. Now the cotter holes here which are 6 thick, will be made once we make the complete cotter, because it is to suit the cotter size. Okay, so next we will go with the spigot end. So in the spigot end we have dia 25, which is 30 long, dia 44, which is 12 long, and then dia 32, which is 84 long. Okay, so we'll make this again in the right plane. So starting with the right plane, here you can say left, you can select the left and you can select the plane. So now the plane is in, you can see this XY axis, it is in the left plane, and here I will make a circle of diameter d, enter, 25, diameter 25, and the length extruded on the side will be 30. Okay, I'll rotate that again, circle, diameter 44, we have a collar of 44, select this and extrude on the side, or we can say first I will go back to wireframe, move this circle to its center, okay, and then extrude. So we have an extrude of 12, a collar of 12. Next we have circle, diameter 32, and its length is 84. So extrude 84. Okay, you can also move the entire thing here, move from here to here. Okay, you can do that, and now we can make a union of all these bodies. Union, presenter. So this is one complete rod, or you can say the spigot end. Okay, so in all of this, if you have seen, we'll make the, there are fillets. Okay, there are fillets at the ends, so we'll make these fillets once we have the cotter. Okay, once we have the cotter holes, so we'll make the fillets later. So we'll now go to the cotter. Cotter, you can see very simple, it's 100 in height, 34 on the top end, 26 at the bottom end, radius 50, wedges on both the sides, and it is 6 thick. Okay, it is taper on the right side. So here we are. Okay, we'll go to the world coordinates again. Okay, going back to the world coordinates, and now we will actually make our, this is the top view. Okay, so we have to go to the front and select the view. Okay, so now here I will make the cotter, select the line, auto mode on, 100. Okay, now on the top side is 34, on the bottom side it is 26, and then join them. So we have a taper. Now I will make an extrude. Before making an extrude, what we have to do is we have to join this. So I will use the command join, and you can see all these edges are, or they are different objects. So I will select all of them and join them together so that I will get a complete solid object. Okay, I'll turn it into 3D so that whenever we extrude, we'll give the thickness 6, and that's it. Okay, now we have to make the wedges. Now the wedges we have to make separately. So I will again go back to this, rotate. Okay, so I will make the wedges in here only. So 34. Okay, Same here, 26. Okay, so now 34 and 26, but now the wedges have to be carefully made. So here I will go to arc, start, end, radius. Okay, start, end, radius. So I will have this side here first, start, end, and the radius you can give as 50. Okay, so the arc is made. Again, same thing, but start on this side. For the year it will be on this side because the arc will be on the bottom side. Start, end, sorry, start and radius, start, end, and radius 50. Okay, now just turn this into a 3D mode because we want to make another wedge or another arc in the about x-axis, so it will be in the z-axis now. So here in the z-axis I will create one thickness, one line of thickness 6. Okay, because the thickness of the wedge is thick 6. Okay, same goes here at the bottom, 6. Okay, now at the half I have to have a curve. Okay, but at the half I will make a vertical line in y-axis. Okay, but what should be the length? So in order to see what should be the length of that particular edge, we will check the length here. Okay, the maximum length, okay, of this particular arc from its base is 2.9. Okay, 2.97. So we will take 0.1 mm extra. Okay, just increment of 0.1 mm. So from here I will give the length as 3.1. Okay, it was almost 3, 2.97, so it was almost 3, so I will take 3.1 here and press enter. Okay, from its midpoint, not on the ends. Okay, and it should come above. Similarly, a line on the bottom side. So we will check again as per the radius. What is that? 1.72. Okay, so we can take 1.82. Okay, yeah. Now in order to, if we see that in which plane we are, okay, right now we are in the front plane. Okay, you can see, but in the front plane we will not be able to make an arc in this direction. This, if we go to the world, it is in the right plane. Okay, so what we'll do, we'll select directly right here and it will be aligned to the right plane. Okay, so now we will make an arc, a 3-point arc, from 1, 2 and 3. Okay, similarly we will make a 3-point arc here also, 1, 2 and 3. Okay, so now we don't want this edge, it was just for construction. Okay, similarly here. Okay, now we have to join these two. It will be extruded along the x-axis. Okay, and this will be extruded along the current z-axis. Okay, so now here I will show you. So we will join these two edges together. You can see. Okay, and see currently these two objects are different. So we will join these two objects together. Okay, similarly we will join these two objects together, and same goes with this. Okay, so you can see now when we select, okay, all are together. Oh, this is separate. Now we will extrude. Okay, this till 6. Okay, and we can extrude this till your 34 length. Okay, so if you see in the conceptual, it will be something like this. Okay, now We'll do the similar operation of extrude here also. Extrude till here and extrude till 26. Okay, once this is done, what we are going to do is we are going to make an intersect. Okay, so solid intersect, you can see here, solid intersect. Okay, so select this command and select both of this solids together, press enter, and you have a wedge. Okay, you have a wedge that is created. Okay, so we'll do this same for the bottom one. Intersect, select both the solids together and press enter and check whether we have got the edge. Okay, so this is the wedges are created, and now we will move these wedges on the cotter and we will make a union. So first I will move this up to a corner. I'll take the same corner. I'll move this also in the same corner, and I will check from all the sides whether it has been properly attached. Okay, so now I will make a union of this entire solid, two wedges and the cotter body. Okay, so this is your cotter, and if you see from your front, the cotter is complete.